Hello everyone, my name is Arslan Maqsood and today I am going to represent my research topic, which is optimization of supply side and demand side management in smart grid. Starting with my topic, first of all I want to introduce what is the smart grid and how are they effective with respect to our traditional infrastructure of electricity. Smart grid is the evolving transition of conventional electricity infrastructure into advanced and modern power system networks. Secondly, smart grids systems are capable of delivering power in more controlled way and more efficient way from supply side to the demand side. So, what is basically the infrastructure difference between the smart grids and traditional grids? This diagram represents the infrastructure of a smart grid. And if we see smart grid, basically they accommodate the integration of the renewable energy sources inside it, and in this way they can enhance the capacity of the supply side. Like if we see, we can integrate the wind sources into the smart grid and we can utilize the power of the wind sources. We can also use the energy storage systems like solar energy system. So these strategies can enhance the capacity of our supply. And on the other side, the conventional infrastructure of the grids is basically can only accommodate the, like it can only utilize, we can only utilize in this way the nuclear plant, oil and coal plants. So in this way, this is basically the traditional hierarchy of our system. Like it contains power generation, transmission grid, and only in the last it's distribution grids. So what thing is basically differentiate the smart grid and traditional grids? Smart grid contains advanced metering infrastructure, which is called AMI, smart metering, smart monitoring and measurements. It also has the independent power communication lines that communicate between the grid and the client. This is two-way communication infrastructure, and it requires the two-way communication protocols for the effective and precise measurement of the demand at the supply side. So some critical factors in these smart grids optimizations, they are like during the power flow through the smart grid system, there are some critical issues that relating to the optimization of the advanced information and communication systems, because when we enhance the complexity of the system through advanced communication protocols, advanced strategies for load control, so these complexities require more efficiency, more effectiveness, and more optimization. And one other thing, that integration of renewable energy sources. These sources impact on the system, like they can cause the fluctuation in the system. Voltage regulation, like voltage dips, voltage sags and swells in the system. They can also cause the load balancing in the system and frequency mismatching. So these are the issues that can be created in the integration of the renewable energy sources in the smart grids. So in my literature review, I extensively discussed about the demand side management and what are the categories that can be divided demand side management into further categories. That are the energy efficiency, time of use, spinning reverse, demand response, and what are the control strategies for the load. Basically, direct load control is differentiated into two categories: classical direct load control and distributed direct load control. So further in our research design, we will discuss these strategies and how they can be effective for our design. So load modeling is also an important issue. We need more precise and more accurate load modeling. These mentioned technologies can be produce effective results for load modeling, demand shifting, visual storage, load power plants, and distribution spinning reverse. So my design basically covers my research question, that is the integration of smart loads at this supply side and the integration of the renewable energy sources, and how we can utilize the both technologies at the same time. So this is my proposed design, the conceptual agent-based design for the precise feedback for the smart grids. Like if we see in the diagram, it is basically an agent-based strategy that can provide a proper feedback to the demand supply side, that how much load is using at the supply how much load is being utilized at the supply side, and basically it can control over the appliances during the renewable energy penetration. And there are in this methodology we can use the both classical load direct load control and distributed direct load control at the same time. Like when our load, the supply side, when our supply side is wants to utilize the integrated renewable energy sources, so it can use the distributed direct load control at the supply side, so they can measure the precise load at the user end. The further illustration of my design is basically it is the mutual information sharing between consumer and the grid. If we see in the diagram, it shows the grid side and the house infrastructure of the user. So basically at the same time the user and the load and the grid are mutually sharing the information. So this system, in this methodology, we can achieve the load balancing, frequency matching, and reduction in fluctuation during to the integration of the renewable energy sources, and smooth circulation of energy can be possible in that way. So in the end, it's the reference list, and thank you very much for listening. Have a good night.